Hello, welcome. Today I try to solve another Leetcode problem, 882, reachable nodes in subdivided graph. So let me first explain this problem. So for this problem, we are given a graph. For example, this is a node 0, 1, and 2, and 0 connected to 1, 1 connected to 0. They are bidirectionally connected. And inside the edges, it is a 0, 1, 10, 0, 2. We can ignore the third value. Yeah, we just type 0 and 1 connected, 0, 2 connected, 1 and 2 connected. Yeah. And what's the meaning of this 10? This 10 just means in between there are 10 nodes. So we're gonna count it as 10. Actually, this is a cost for the graph. Yeah. And now the return, we also have a max moves of 6. This means from this starting point 0, we can move 6 places, 1, 2, like 3, 4, 5, and 6. Yeah. And we are also giving the number of nodes 3. And we are going to return, yeah, let's check the return. So return the number of nodes that are reachable from node 0 in the new graph. So inside the new graph, we are going to count how number nodes that are reachable from this node 0. So in total, as you can see, there are 13. Why? Yeah, let me enlarge the picture a little bit. And now you can see why it is 13. Yeah, let me still enlarge it. Yeah, like this. Yeah, as you can see from here, from 0, we're gonna move 6 positions, 1, 2, 3, 4, 5, and 6 up to this node. Yeah, because the color is yellow, a little bit different. Yeah, they make a drawing, but this drawing is not so clear. But when you enlarge the picture, it is very clear to see. Yeah, and from this side, 1, 2, 3, 4, 5, 6. Yeah, and how many nodes in total? While you count it, it's gonna be 13 because yeah, let's just count it. 1, 2, 3, 4, 5, 6. Yeah, 7, 8, 9, 10, 11, 12. And this 0 should also be included. When you include this 0, it is 13. So how many nodes that is reachable from 0? So for this 0 node, it is also included. That is why it is 13. Even though the description didn't mention that, but we can guess. Use this example. Yeah. Now let's check how we gonna solve this problem. Yeah, I think I'll make a drawing first that gonna be easy to understand. What does it mean for that result? For the result of this kind of calculation. So let me prepare the drawing. Yeah. So let's prepare 3 nodes. So this is 0, this is 1, and this is 2. So 0 and 1 are bidirectionally connected. 0 and 2 also connected. So just imagine here. Yeah, let's check this example. So 1, 2, and 10. So here, 0 to 1, there's 1 node. 0 to 2, there are other 2 nodes. Yeah, and this is a big node, and also for the node 2 and another 0. But for 0 to 2, there are 10 nodes, if I remember right. Oh, 0 to 1, there are 10 nodes. 1 to 2, there are 2 nodes. Yeah, 1 to 2 are 2 nodes. But 0 to 2, there's only 1 node. Yeah, so let's just make a 1 node, and 0 to 1, yeah, let's just make 10 nodes. So I just drawn 3 nodes, drawn 5 nodes. Yeah, but actually here should be 10 nodes. Yeah. Later on, I'm gonna use this example to explain how to solve this problem. Yeah. So we are also giving the edge and the nodes in between. Yeah. And we can use this node to calculate the distance from node 0 to node 2. So from node 0 to node 2, what is the distance? The distance is all the edges. So in between, here is one edge, and here is another edge. So the distance from 0 to 2, it is 2, because there are 2 nodes. And the distance from 0 to 1, so what is the distance? Because in between there are 10 nodes, and we also need to include one edge, because 0 and 1 connected to that 10 nodes. So in total, it's gonna have 11 edges from 0 to 1, including those smaller nodes. And from 1 to 2, there are 3 edges. So this is 1, 2, and 3. Why we gonna count the edges? Because according to the edges, actually it is the distance. So for example, if the distance from 0 to 2 is 2, so the max move if it is 2, so from 0 node, definitely it can go to node 2. Because inside of the Dijkstra's algorithm, I'm gonna use the Dijkstra's algorithm to solve the problem. Yeah, from 0 to 2, the distance array for this node 2 is gonna be 2. Yeah, because this is 1, this is 1, 1 plus 1, it is 2. So it means this node 2 is reachable from node 0. Yeah, so I'm gonna count it as a node 2. And this 0 is also reachable from because inside the Dijkstra's algorithm from the beginning, this is not 0 to 0, it is a 0. 0 is less than the maximum of 2. Yeah, but this is just for the maximum of 2. Yeah, so we calculated the node, the big node first. Yeah, we can use the Dijkstra's algorithm to calculate the biggest node first. Because we're gonna have a distance array. According to the distance array, we can check if the big node, which one is reachable. 0 and 2 are reachable, 1 is not reachable. Because as you can see, the distance is 11, the distance to this side, it is 2 plus 3, it is 5, so it is not reachable. Now, we're gonna check the smaller node. Maybe there are some smaller node which is also reachable. So how can we check the smaller node? So the smaller node can go from the node 0 to 1, or it can go from node 1 to 0. Why? Because currently the maximum is 2. So what about, it's like the question, the maximum is 6. So it means from this side, it can move 6 positions. And also from this side, from node 1, yeah, from this side, it can go up to how many positions? This is 1, 2, 3, 4, 5. It can still move to 1 position up. Yeah. But if this max move may be bigger, if it is bigger like 10 or 13, so it means there will be an overlap inside those smaller nodes. Yeah. So how can we calculate it? Actually, this is not so difficult. So we should use mathematical tricks. So if there is an overlap, we're gonna take the minimum value. So the minimum value, because we've already calculated the biggest node, we only need to calculate the smallest node. So if there is an overlap, it means inside this circle, those 10 smallest node must be calculated. So it's gonna have a 10 because there is an overlap. Yeah, if there is no overlap, we're just gonna check from this side. I'm gonna have a count. For example, this is a node U, and this is a node V. I'm gonna have a count U and a count V to check how many of them. Maybe it is not reachable from this V, so I'm gonna just check if it is reachable from U. Yeah, if it is not reachable from U, maybe I gonna check how many nodes which is reachable from V. Yeah, as you can see, there are so many cases, but which case is not possible. So if the distance of this U and the distance of V is already more than the max moves, maybe the max move is 6. If it is more than 6, it means this is not reachable, and this is also not reachable. So inside those smaller nodes, it must not be reachable, because if the biggest node is not reachable, the smaller node in between inside must not be reachable. Yeah. So according to this mathematical calculation, we can go back to the code editor to finish the coding. As I said, I'm gonna use the Dijkstra's algorithm. I'm gonna get a distance array. I'm gonna use the distance array to calculate it. Yeah. So let me just copy some randomly Dijkstra's template code to calculate it. Yeah. No, I just copy this one. I think every Dijkstra's code should be okay. Yeah, let me just copy here. Let me randomly copy some Dijkstra's code. Yeah, and make it a little bit smaller. Yeah, let me make it bigger actually here. Yeah, so let me change a little bit for the Dijkstra algorithm. So here I'm gonna prepare a graph, and here is UV, and this W is the number of smaller nodes in between. So as it is starting from 0, I will not -1 because the node will just start from 0, so I will delete the -1 part. So here is the distance array, and let me check the start node. So the start node is just 0. Let me change it to 0, and the distance would be 0. And for the PQ, it's gonna be the distance 0, and the starting node, I'm gonna change it to 0. I don't need a modular. Now, this is the weight, and this is the node. I'm gonna pop it out from the PQ, and this is its neighbors V and C, and this is the cost from this node U to node V. Yeah, but here I need to check this one. Actually, for the weight, it should be +1, because if it is +1, it is the distance from 0 to 2, it is 2. Otherwise, the distance would be 1. It is not useful for my calculation, so I have to use the weight +1. Yeah. Now, if everything's okay, I got a distance array. So inside of the distance array, I can calculate the result. Yeah, let me just print out the distance array to check if it works. Yeah, let me return a 0 first. Yeah, let's check the example 1 and check the distance array. Yeah, so for example 1, distance array, it is 0, 0 to 1. It should be, yeah, I think, is there something wrong with this distance array? Yeah, let me check, maybe there's something wrong. Yeah, let me first print out this graph. Yeah, so the graph is okay. So the 0, it is 1, and 11, so it is 2, and for 1, the distance is 11 and 3, and for the last node 2, the distance is just 2, distance is 2 and 3. Yeah, so it means it is okay. Yeah, it means this is also okay. Yeah, I think the distance array is okay. Let's just check it. Yeah, because the distance is the shortest path. So 0 to 0, it is 0. 0 to 1, it can go to this side, it is 5. And 0 to 2, it can go to 2 directly, 1 and 2. So it means the distance array is right. Yeah. Now I'm going to use this distance array to calculate the result. First of all, I'm gonna calculate the big node. So the big node is just 0, 1, and 2. I'm gonna check how many big nodes that is reachable from 0. Yeah. So just for D, yeah, actually I can calculate it directly. I'm gonna use a sum. D should be more than. Yeah, let me check. This D should be less than and equal to the max of moves for D inside the distance array. So for this one, I'm gonna calculate the biggest node first. So in this example, the max move is 6. It means I'm gonna have a result of 3, 0, and 1, and 2 will be inside the result. So currently the result would have a 3. Now I'm going to check all the edges because I'm gonna check the smaller node, how many smaller nodes that is possible. So for still UV and W inside the edges. So if, yeah, I'm gonna check the distance of the biggest node. So the distance of U is more than and equal to the max of moves, and distance of V is also more than and equal to the max moves. It means, yeah, so for example, if the max move is just 1, yeah, from 0, so this one is 2, it means already more than 1. And for the not 1, the distance is 5. It is already more than 1 because the max move currently is 1. It means inside those two nodes, that is not possible. So what I gonna do? I gonna use a continue, just jump through this, yeah, jump through this this edge and go to the next edge. Yeah. Now I'm gonna have a count U. I'm gonna have a count U. This means if this is not U, this is not U, and this is not V. I'm gonna start from yeah. I'm gonna check if this not U, how many nodes can reachable from this not U side or this not V side. Yeah. So it's gonna be at least have a 0 because I'm not sure, because this is just add. If it is an or condition, it means the dist U should be less than or equal to max of moves, and distance of V should be less than and equal to max moves. Yeah, so I have to check the max because it cannot be the negative values. Yeah, it would be the max of moves minus the distance array distance of U. Yeah, let's use this example. The max moves is 6. So from 0, if this is the U, so the distance of U here, it is 5. Yeah, the max move is 6. 6 minus 5, it is 1. It means I can move one step. I can move to this node. So I'm gonna have a count U. So this is a count U. But I cannot have negative values. Yeah, if it is a negative values, I'm gonna keep a 0 for the count. And similarly, I'm gonna count V from the other side. So I just need to change it to V. Let me change it. Oh, which is the lowercase, I don't know. So yeah, let me change it to the lowercase V. So it means yeah, from the other side. So it is this side. I'm gonna max move is 6, and currently the distance of this V is 0 because distance from the 0 it is 0. So the maximum is 6. 6 minus 0 it is 6. So it is 1, 2, 3, 4, 5, 6. So it is exactly how many nodes we have. Yeah. Finally, we just need to use the result plus equal to the minimum of this count U plus the count from V. Yeah, actually it's gonna be the minimum of the W because W is how many nodes in between 0 and 1, and there may be the overlap, so we're gonna use a minimum of W. Yeah, and finally we just need to return the result. If everything is okay, I think I can got the right result. Let's just check it first. Yeah, as you can see, it passed. Now let me delete some print and submit it. After that, I'm gonna analyze the time complexity. Yeah, as you can see, it passed and it's pretty fast. Now let's analyze the time complexity. Let's check how many nodes. So the edges will be 10 to the power of 4. It will be n squared, and the nodes will be n. Yeah, and the value of n. Yeah, so this is just a count. Yeah, because there may be. Yeah, this is just the count is just for the cost. It will not consume the time. Yeah. So for the Dijkstra's algorithm, the time complexity will be E log V. E is the number of edges. So the number of edges is 10 to the power of 4. It is n squared. And the V is just n. So the time complexity is n squared log n. And it's gonna not be a big number. That is why it is so fast. If you think this is helpful, please like and subscribe. I will prepare more graph problems like this. See you next time.